Okay, so we have question 10. It says the diagram below shows 3-point charges, A carrying a charge of negative 4 nanocoulomb, and then B carrying a charge of positive 8 nanocoulomb, and then N carrying a charge of 2 nanocoulomb. These point charges are placed at a distance apart from one another as shown in the diagram below. Then 10.1 says state Coulomb's law in words. Right, so for 10.1, this is how we state Coulomb's law. So Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of their charges and inversely proportional to the square of the distance between them. Right. Now, we have 10.2. It says, calculate the magnitude and direction of the net force around point charge N due to the presence of both point charges A and B. Right. So this is how you calculate that one. So we'll say, let's first start by calculating the electrostatic force of N due to A. Right. So the first thing that we want to do here is draw a free body diagram to show the electrostatic force that will be experienced by N due to both these charges. So we have N will move towards this direction to the right due to A. So this is the electrostatic force of N due to A. But then looking at its relationship with sphere B here, we can see that sphere B is positive and then also sphere N is positive. So there will be a repulsion force between those two spheres or those 2 point charges. And then this will be the force of N due to B. Right. So now you get the whole point. So this is the force of N due to A as it is attracted towards A. And this is A is the force or the electrostatic force of N due to B as it is repelled away from B. Right. Then in having to calculate here, we apply our formula F is equals to K, Q1, Q2 over R square. Then our K is supposed to be 9 times 10 to the exponent of 9. And then our Q1, now remember, we can take that as our charge N, which here we are told that it is carrying a charge of 2 nanocoulomb. So that's 2 times 10 to the exponent of negative 9. Remember your conversions. If we have nanocoulomb, this converts to times 10 to the exponent of negative 9. We had microcoulomb. This is the one that converts to times 10 to the exponent of negative 6. So always keep your conversions in mind. Then your Q2, you're going to take it as the charge on A. So the charge on A, we were given negative 4 nanocoulomb. But then remember, in this formula, we don't substitute a negative. So that's 4 times 10 to the exponent of negative 9. Then over the distance in between charge N and charge A is 14 millimeters, right? But then remember, we do not have our distance in millimeters, we have our distance in meters. So whenever we have millimeters and we want meters, we need to convert that by dividing by 1,000, right? So it's divided by 1,000. And then if we have centimeters, we want to convert to meters, we divide by 100. So these are the conversions that you always have to keep in your mind, right? So if we take the 14 divided by 1,000, this will give us a 0.014, or someone might write it as 14 times 10 to the exponent of negative 3. Still one in the same thing, right? Now you will have to calculate that. So punching that to your calculator, 9 times 10 to the exponent of 9, then times 2 times 10 to the exponent of negative 9, then times 4 times 10 to the exponent of -9 as well. Then here we have 0.014 and then square. So punching that into our calculator, we get 3.67 times 10 to the exponent of -4, then newtons. Okay, now let's then calculate the force of the electrostatic force of N due to point charge B. Again, the formula, and then that's K Q1 Q2 over R square. Now let's substitute. We have 9 times 10 to the exponent of 9, while Q1 again is the charge of N. So that's 2 times 10 to the exponent of -9. And then here we have B, we are told it's 8 times 10 to the exponent of -9, right? Over the distance now between point charge N and point charge B, we have to consider is the 14 millimeter plus the 35. So 14 plus 35 gives us 49. Then we have to divide that by 1,000. So we have the 49 here, 49 millimeter. Then if we divide it by 1,000, that's 0.049, then square. Now if we punch all that into our calculator, we have 9 times 10 to the exponent of 9, then times 2 times 10 to the exponent of -9, multiply again by 8 times 10 to the exponent of -9, and then 0.049, and then square that. Okay. So doing this one, we get 5.99. So we're just gonna round it off to 6. Let's round it off to 6. So it's going to be 6 times 10 to the exponent of -5 newtons. Right. Okay, so now that we have this 2 here, to calculate the F net, remember, this is where we now need to consider the directions. So we will say this one here, because it's due to B, was going to the left, as indicated here. And then this one is due to A, was going to the right. Now, if we are to take right as positive, that means positive for the value in here, and then negative for the value on the left. So to calculate our F net, need to say F net is let's call this F1, and then let's call this F2. So this will have to be F1 plus negative F2. So my F1 is 3.67 times 10 to the exponent of -4 plus negative F2. So this is F2, and then this is F1. So F1, F2 times 10 to the exponent of -5. And then let's punch in our calculator. We have 3.67 times 10 to the exponent of -4, then plus negative 6 times 10 to the exponent of -5. And then we get our value as 3.07 times 10 to the exponent of -4 newtons. To which direction? Because it's positive, that means it's to the right. So that's how you were supposed to calculate that for a total of 5 marks. And then the whole question was just for 7 marks, right? So pay attention to how I went about answering that question. All the best.